The company was founded by Charlie Tannhauser in 2002, and Conquer Blue is a privately held company. We've got approximately 200 employees, and of those, about 60 are engineers. We're headquartered out of Dusseldorf, Germany, and we have offices in Mumbai, India, UAE, and also in the USA, which is where I'm situated. We're the inventor, owner, and engineer and the licensor for the Conquer Blue reformer, which I'll show you is really a unique method of converting waste into useful products. Basically, we have patents and patent-pending technology worldwide, and we use an advanced system of thermolysis and staged reforming to convert waste into syngas, and then we use that syngas, as you all know, into separate products that have value in each market. Basically, we turn a whole variety of wastes. We have a lot of flexibility with our technology, and we service private industry, municipalities, federal governments, and also we work with energy project developers around the world. We sell integrated systems to third parties, and we also participate, not on every project at all, but a few of the projects we actually participate as an owner and operator. If you look at the technology itself, it's basically a method of indirect heated thermolysis, and we use ceramic heat carrier balls in a circuit that go from the top to the bottom. And basically, if you look at the bottom right, and I'll get my little pointer on here, if you start down here, this is where we take char out of the pyrolysis vessel, and we fully oxidize that to create hot gases. And the hot gases are then used to heat up our ceramic balls up here in a refractory line vessel. The balls travel by gravity down to the gas reforming vessel right here, and then they've cooled off a bit, and then they come down here into the pyrolysis zone, where we actually do the volatilization of the material. They then have a mechanical lift to move their way back up to the top of the system. The gas, which is created gas rises from this pyrolysis vessel up to the steam reforming vessel, and from there it then goes out to the syngas cleanup circuit. I haven't shown, obviously, a lot of the details about the waste heat integration in this system, but we do pay a lot of attention to that to try and improve the overall efficiency. Basically, it's a system where we're able to keep oxygen either through air or an ASU plant out of the system altogether. We do use nitrogen for safety to create purging in the system and make sure oxygen is not in the system. Again, the key to the technology is the use of these indirect ceramic carrier balls. They're probably about that big in diameter, and they hold up really well. People ask us often, well, gee, how long do they last, or do they break apart? These things are really rugged, and we probably don't replace more than 1% of the total volume per year. Basically, then we use the flue gas, as I said, from the char burner to heat up these carrier balls, and that completes the cycle. Well, how are we different as a technology? Well, first of all, we're modular in nature. We basically can shop, build, and manufacture modules, and then when they're delivered to site, we use a crane, and they're basically stacked up one on top of the other and bolted together. And so these units come together very, very quickly in the field. We do have an air and oxygen-free process, like I mentioned, and we assist that with a nitrogen purge for safety. We get, as a result of the steam reforming and the exact temperature and heat carrier conditions that we can vary, we end up with a really low tar syngas coming out of that middle vessel. This is a fully automated system, and we can adjust the steam injection rate, we can adjust the mass of carrier balls we used in the system, and we can also adjust the flow rate of the carrier balls through the system. And these factors combined give us a lot of flexibility to produce a gas that might be more heavily oriented towards hydrogen, or a gas that's more heavily oriented towards carbon monoxide. After cleaning, we can take our gas and go into a syngas certified reciprocating engine. We've been working with MWM, and in fact, they will warranty their engine based upon the quality of our syngas. We also can use it for, and some projects have used it for hydrogen purification, creating hydrogen as an end product, and as well we're looking at liquid fuels and chemicals conversion with certain partners that are out there working in this area. I want to talk for a minute about our commercial projects and also projects that are advanced development and construction. I'm not talking here about our previous pilot projects that date back to 2002. There are probably about 5 different projects I could talk about, but in brevity of time, I've decided to leave them out here. But basically, there was a lot of pilot work done to get to the stage where we actually have these commercial projects. We have a small project in Mumbai, India. It's using a mixture of MSW, medical waste, and tires. It's only a 180 kilowatt thermal system, generating about 63 kilowatts of electricity. One of our licensees in Omuta, Japan, has put in a plant solely based on sewage sludge, about 15 tons per day, and they're making hydrogen as the product. So not electricity, not liquid fuels, but actual hydrogen that's used by 3 or 4 local industries in the area where they have that project. That's been operating since 2011 and represents our 2nd generation technology. In Mahad, India, we have a plant that we own that's servicing a pharmaceutical company. And basically, we take the waste products from their process, we go through a membrane separation to help concentrate it, and then we use waste heat from our process to dry that to a solid, and then that goes into our reactor, and we end up making a kind of a fuel gas substitute for the industry to use. That's rated as 3 megawatt thermal, and it makes about 1,200 cubic meters per hour of syngas that goes to the industrial process, which we sell to them. In Pune, India, this is our largest project to date. This is a very big project that Conquer Blue won through a competitive tender. Kind of, you look around the world where we're active in development, we're actually doing tenders. I would say by far and away, India is our most active market. I'll get to a second project in a minute on the next slide. With this project, it's basically in 2 phases. The first phase is complete and became operational in the summer of last year, July of 2012. And basically that's taking in about 1/3, or 333 tons per day of MSW. We have a MRF on the front end that does some level of separation. So we're separating out kind of the non-reformable material from the reformable material. I really wouldn't call it a traditional recycling plant because most of this waste has been picked over before we even see it. So we're dealing with really a pretty wet organic waste stream that comes into our process. Again, we use waste heat that's generated in our process for drying, and we dry the material to about 20% to 25% moisture content before it goes into our reformer. And we're using a single engine 2.7 megawatt, which is really a 4 megawatt rated engine on natural gas, but in using syngas, the manufacturers derated. And so it's a 2.7 megawatt electrical output. And we've got the second 2 towers, towers number 2 and 3, be coming online in the February, March, April timeframe in 2014. We'll be adding 2 more engines of 2.7 megawatts each. So we'll have a total at that site of 8.1 megawatts of electricity servicing the Pune area.